Welcome everyone to Apidays Paris and our API Academy workshop. Quick introductions. Everybody's not in the room right now, but the players of the day, myself, I head up API Academy. Francois over here, he is API Strategy and Security. Aaron in the back happens to be our corporate API expert. Christian Oberle, I have no idea where that came from. I need to fix that, is our field expert. He'll be talking later on. And then we have two partners with us. Frank Arts is the founder and CEO of EnableU, and Marcus Muller is the CTO of Apida. They'll both be doing some interesting sessions today. And this is the actual schedule that we'll be covering. So we'll start with the intro. That's what I'm doing right now. We'll cover really quickly what API Academy is, as well as our certification program. And then we're going to get into the real meat of it, going over to Francois, who will be talking about GraphQL. Frank will come in and talk about API operations and security. And at that point, we're going to take a break. At 3:40 firm, we're going to take a break. We have a beautiful lady in the back room who's basically going to say, shut up, get out. At the end of the break, we'll come back with the key benefits of a successful API strategy with Marcus, followed by customer considerations and cloud adoption with Christian. What's in the future for APIs with Aaron, and then we'll wrap it up, and that'll be the end of the day. So with that, let me get into the history of API Academy. First of all, for the people in the room, how many of you are familiar with API Academy? Well, I know you are. So it's been around since 2011. It was created in 2011. If you think about where APIs were at that point, they were beginning to emerge out of the SOA and ESB world. And what the industry really needed was thought leadership. It needed evangelism. And that's exactly what API Academy was. It was a group of leaders, and you can see some names across the bottom, and you'll actually see a few familiar ones, including the founder of Apidays. That's all they did was run around the world and help enterprises understand the extension of SOA and ESB into an API-centric strategy. They held workshops around the world. Oh, yes, absolutely. They held workshops around the world that designed for not just enterprise-centric, but also they were doing general workshops at places similar to what we're doing today. And they wrote a lot of blogs on API Academy on thought leadership. This model was in place from 2011 to 2018, and I'll cover what happened at that point in 2018. But literally, API Academy wrote the book on API strategy, design, and security thought leadership. These are some of the publications that were created in that time frame, 2011 to 2018. These are still available today, either through API Academy or through O'Reilly, so Amazon. So continuous API management is a good example. That's available on Amazon. Many of the rest of these are available for free on API Academy. In 2018, we did have a major change take place. And this was, the timing was involved with the acquisition of API Academy and CA Technologies by Broadcom. And it really came down to, we looked at the big picture, and evangelism was no longer an issue in our space. APIs are a reality. Everybody is dealing with the reality of, I need APIs in every aspect of my business. So it really was more about best practices, and that's been the shift for us. We've looked at API design, API strategy, and API and microservice security. What can we do to help enterprises get the best value out of API management in those areas? So we renewed our focus on education, thought leadership blogs, and how-to videos through the website. So it's very website-centric now instead of in person. And we created a brand new program, not around product, but around personas. And that basically is the first industry agnostic independent education and certification program available in our industry. It's a personalized, self-paced courses for these personas: API designer, API security architect, and API product manager. It's best practices centric, and it's on demand. And I'll give you an example of what it looks like in just 1 minute. But you can see some of the badges on the right. Once you go through the entire curriculum, You take the final exam, and I assure you this is not a casual sit down and, oh, I watched the video so I can take this exam. You actually have to understand best practices in these particular areas. Once you get your certification, we encourage you to go up to our LinkedIn page and let everybody know. It's pretty cool. If you go up there, you'll see a lot of people saying, hey, look what I just got. We do still do worldwide in-person training. This is an example of one right now. And we've been API Day centric in doing these because, again, with the focus on Mehdi being one of the founders of API Academy. If you go to apiacademy.co, and this is what it looks like right here, you see up in the upper right, get certified. Click on that, and in this case, let's say I'm gonna take the API Security Architect course. So you click on that, and what it's gonna do is give you a standard curriculum that's based on a computer learning system. And you'll go through all the modules, and at the end of it, you get a certificate or you don't pass on the first try. It doesn't matter, you get multiple tries. But you get this is what we ask you to share. So in summary, I'm gonna get out of the way and let you guys get to the meat of this, but API Academy is all about API and microservices, best practices around strategy, design, and security, and everything on our site is really focused on one of those areas. If you go to apiacademy.co, again, you'll get best practices, you'll get how-to videos, and you'll get in-person events such as what we're doing today. What's gonna happen with these sessions today is they'll actually be uploaded next week to API Academy as blog videos. And the certification program is available now. We encourage you to go check it out. It's been getting pretty good reviews, and it's a self-driven machine. We get 20 to 30 people signing up every day to start getting a certification in one of these various personas. So with that, I will, first of all, are there any questions? Then I'll turn it over to Francois.
Thanks, Bill. I will talk to you about API security considerations for GraphQL. My name is Francois Sells. I'm Distinguished Engineer at Broadcom, the Layer 7 division. So I get started. So GraphQL is showing up in your architecture. There is no turning back. So what we're seeing at our customers is that GraphQL is the top asked for modern protocol. We get a lot of requests to do GraphQL related things these days. This is very, very topical for us. We're noticing that GraphQL is being chosen for new APIs at our customers, especially for private or internal APIs. I overhear customers say things like, we are standardizing on GraphQL for, whatever their architecture is. But it is something that is definitely here to stay as far as we can tell. And what I'm going to try to address in this presentation is how does that affect your API infrastructure, in particular when it comes to security. So these are the topics that we're going to go through in this presentation. And we're going to look at why patterns that are established for today's standards, like REST APIs, why aren't these standards aren't always adapted for GraphQL? And we're going to break it down across these things. So we're going to look at GraphQL and authentication, GraphQL and authorization, the API infrastructure loss of context that comes with GraphQL and how to restore it, best practices around GraphQL, and in particular, I'm going to talk about whether or not you should turn off introspection in production environments. I am going to talk about the impact on rate limiting, so why per request counting is broken. And I'm going to look at query cost analysis in the context of security and vulnerability mitigations. And I'm going to describe 3 different approaches to that: a basic cost analysis, a cost modeling, and a cost learning. So let's start with authentication. What are the GraphQL specific authentication patterns? And this is it. There aren't any. Authentication should not be GraphQL specific. Authentication should be decoupled from your API implementation, right? This is something that we recommend all customers to do. But there should not be anything GraphQL specific about your authentication, in the same way that there probably shouldn't be anything REST specific for your REST APIs when it comes to authentication. It should be orthogonal, if you want. So things like OAuth, JOTS, MTLS, etc., all of that applies to GraphQL APIs in the same way that it applies to what you're doing today for REST APIs. And that's unlike, for example, if you remember the SOAP days and WS star standard and stuff like that, where you had some patterns that got involved in authentication that were really specific to those protocols. In the case of GraphQL, the patterns that are in place today that are established are still the best practices for authentication for GraphQL. For authorization, though, it's a very different story. So I'm going to start talking about authorization GraphQL, looking at a coarse-grained authorization. So if you're coming at this from like a REST context, you've been doing REST APIs for a while, there are things that you're accustomed to with your authorization that no longer apply. So previously, meaningful transport characteristics lose their status. So the HTTP URI, which gets involved in coarse-grained authorization by identifying the resource identifier, is no longer applicable to GraphQL, where you have a single endpoint. The HTTP verb that, for authorization purposes, we rely on to get a high level or a coarse-grained identification of the action, the method that you're doing, is also no longer relevant, right? GraphQL, everything is HTTP post. And even the HTTP status coming back in the response, which tells you, is this, 200 is a success, 500 or something like that is an error, that gets involved in authorization in some cases. So that is also something that lost its meaningfulness when it comes to GraphQL. The query details are expressed in a custom syntax in GraphQL, right? So the additional context for a query or a mutation is buried deeper than it is for REST, and is opaque to otherwise HTTP-aware middleware. So you have that loss of context. Here are some example coarse-grained authorization strategies that you might be using today for REST APIs that don't work anymore. So for example, you're looking at the HTTP method. That's something that we see people do often, right? So if you got an identity that's associated with an administrative role, maybe you can do anything. But if you're not, you can only do HTTP GET, right? That's just an example. I'm not saying that that's what you should do for every API, but sometimes that's a strategy that gets involved in the middleware. So you can't do that with GraphQL, because in GraphQL, the HTTP verb doesn't tell you anything about the method that's being, the function that you're doing. Another example is to use the HTTP URL, for example, /API/whatever/pattern, right? And then that thing in the middle would be something that you would use to compare against a scope that you have in an OAuth token. That's another strategy that gets used in coarse-grained API authorization. And it's easy for middleware to be able to apply this type of logic. So you can't do that with GraphQL because there are no HTTP URIs in any way that are meaningful. And like I was saying, the response status coming back from a request, right? So maybe you were doing for your REST APIs a count, right? And maybe you can only fail a certain number of times per minute, otherwise you get blacklisted, and something gets applied to that, right? So maybe you're counting errors or the failures, and you do that by looking at the HTTP response call, which is super easy. So for GraphQL, errors come back as an HTTP 200, so you can't do that, right? So this is another example where a coarse-grained authorization kind of falls apart. So peeling the layers, let's look at the anatomy of a GraphQL request over HTTP. And if you are familiar with GraphQL, if you're very familiar with GraphQL, apologize, this might be something you already know, or if you're watching the recording. But GraphQL requests are packaged in a JSON envelope, right? So that JSON you see below, right? So the GraphQL, here I have a mutation. It's called watchout. It's got an input. You're doing something and you're asking for some properties back. So that's actually not JSON, right? That's the GraphQL specific syntax, and then it refers to a variable input that itself is JSON. So that's what it looks like if you're crafting a request for your GraphQL API. And then when you are sending that over HTTP, that's what it looks like. It gets mushed together in one JSON input in which the query property contains the whole GraphQL syntax, and the variable inputs are just follow in their JSON format. So that's what it looks like when you're passing GraphQL over HTTP. So these variables there, that anything that you're doing at the JSON level is still applicable, right? If you're evaluating JSON path or JSON schemas or things like that, you can still do that for that portion of your GraphQL requests, if you like. But the GraphQL syntax itself, like what's inside that mutation, so that's requires a GraphQL specific capability in order to be able to interpret that. So in order to get context around that GraphQL thing, you need to be able to interpret it somehow. And that's what I mean by a loss of context. Some middleware that you're using right now that's HTTP aware, that's used to dealing with REST APIs, is not keeping up with that. And in order to illustrate this loss of context, I'm going to talk to you about this graph bypass attack pattern. The idea is that by moving input data inline of the GraphQL, the JSON input controls are completely bypassed. So look at that query on the left side where you have a mutation. There is a variable input parameter that's in JSON at the bottom there. So that's one way to express that GraphQL mutation. But here's another way to express exactly the same thing. So this is an equivalent GraphQL syntax, right? So you've got a mutation, the same mutation, but instead of having the variables, the input as a variable, you bring it up inline. So you can express your syntax like that. That's still valid GraphQL. But what happens is that by choosing that syntax, if you want, you're moving this input into the GraphQL zone. And so what you were able to prior validate using JSON patterns, you're moving this data out of the JSON inspection domain. So that is a way that you can bypass these controls. That's a maybe dramatic illustration of the pattern, but the point is that you're losing the context, in this case the context of the input of your GraphQL query or mutation. And this is not just about input sanitization. The loss of context really matters beyond security. So potential vulnerability aside, the loss of context affects your infrastructure in many ways. And this is the actual customer requirement that came to us that made us start looking into this. So we have a big customer, it's a telco, and they have this pattern, right? They have mutations where they have inputs that are coming in, their inline input. That's just how their applications work right now. And that value here, that department value, is relevant to them in the middleware, in our gateway. And the customer is used to inspecting something about the query, about something in the REST traffic, and routing the traffic based on that. So they want to do the same thing with their GraphQL. Based on what department is in the input, they might want to route this to different implementations of the same GraphQL. So how do you do that, right? So if these things are in JSON or the HTTP URI, it's great, but now you need something GraphQL specific in order to interpret that. So in order to resolve this coarse-grained authorization problem, and in general the lack of GraphQL context, here's what you need, right? The required context includes the action. Is it a query? Is it a mutation? So far, that's not too complicated, right? By looking at a GraphQL context, you don't need a lot of GraphQL-specific capabilities to do that. But a mutation can be a lot of different things. Right? Is it an update? Is it a specific operation, right? You need to know how your API is structured, what mutation names exist in order to understand what security precautions are applicable. You might want to have different rules based on the types that are accessed in your GraphQL, right? So if this particular type is being queried, then maybe you need a specific role in your identity. You might even want to have rules at the property level. So for each property inside each type, you might have like a matrix of authorized groups, for example. And in order to identify the resource, you need to parse the mutation input, whether it's inline or in its accompanying JSON. This is where you can identify which resource is being acted upon, because some coarse-grained authorization need that input in order to be able to apply security rules. And the alternatives to having that context is basically to pass the ball downstream to the service implementation. And this is a step backwards because we rely on the infrastructure to do that type of validation. And when you're passing the ball to the service implementation, you're losing a little bit the confidence that of having associated with having rules across that are the same across all the APIs, for example. Right, and you have to trust backend service developers for that portion of your security, which is something customers don't like to do. So reacting to that, here's a couple of examples where we are starting to introduce GraphQL context into our API gateway. So parsing granular input, inline input property. So this is a new capability that we added to layer 7 where you can look at a GraphQL mutation and even if it's inline, you can go in and get a specific value inside the input. So you can go into a sub-property of the input. You can parse its value, make it available to policy context. So the customer that was asking for that is using this assertion to branch on the value coming out of it and to choose where to route the request. You can validate additional conditions using all the existing primitives in the layer 7 gateway. This assertion is just filling the gap of giving you information about what is in that input. So this is something that was added recently. Here's another assertion that lets you take a GraphQL schema and basically enforce it during your transaction. So of course your backend service implementation normally does that, like Apollo would give you an error if you're validating or violating something about the schema. But this is a way to do it in the infrastructure in front of the service. So you can load the GraphQL schema at design time. And when we talk about turning off introspection in production, this aspect of this capability is really critical for us. So you've got a behind-the-scenes design time introspection that facilitates the metadata loading, so we can pull it directly from the service backend. But we do encourage customers to take ownership of their metadata, including this type of schema. So it validates queries and mutations against a schema at runtime. You incorporate that into your policy decision tree. But you can also take a schema, take ownership of it. Maybe you reduce it. Maybe you're tweaking at the edge in order to have a GraphQL facade. Typically at the edge, you might want to have a scaled down version of the actual GraphQL implementation. This is something that customers are also looking to do because they're already doing that for their REST APIs and for other types of APIs. So they want to do the same thing for GraphQL, and this is the capability that makes this possible. Okay, that was authorization. Now let's take a look at best practices, and in particular, let's look at introspection in production. I chose this topic because this is something that a lot of people have questions about. Should I turn off introspection in my production environment, right? GraphQL have this really, really powerful and convenient introspection mechanism, but some environments don't need it, right? You have sometimes a GraphQL API, there might be a sandbox that the client-side developers are using at design time, but not at runtime, right? Maybe you've got environments that developers are working against, and once the application is built, it's targeting a production environment, and you will never actually see a legitimate introspection call in these environments. If that's the case, then you should maybe turn it off. So, and this is what that decision tree should be for every graph in a given environment, right? It's not for every Graph API, but for every combo of Graph API environment, you should ask yourself the question, is introspection actually needed here? And the answer to that question needs to be answered by thinking about the developer experience associated to this API in this environment. And if the answer is no, you don't need introspection there, then yeah, you probably should turn it off. Otherwise, leave it on. But leaving introspection on doesn't necessarily mean that it's on for free for anybody, right? If you have authentication associated to GraphQL, maybe that authentication applies to all the introspection calls happening as well. And if you do find yourself in a situation where you're turning off introspection for that specific GraphQL, there's a few other things that fall into the same bucket, right? So for example, error masking. If you're turning off introspection, you probably need to turn off error masking, because the error masking is also kind of part of the developer experience. That somebody can look at the very informative layer that Apollo gives you back and understand where you went wrong, right? So they're very conveniently informative, but if you turn off introspection in a given environment, you probably want to mask this stuff as well. So you can't just, not return an error back, but you want to mask the detail portion of those errors. Error handling. So GraphQL errors come back, like I was saying, with HTTP status 200. So you need to actually parse the JSON response in order to be able to know whether or not you're getting an error or a success. But obviously, don't get too comfortable with that. Security by obfuscation is security by obfuscation. It's not real security. Hackers, if they want to reverse your GraphQL API, will find a way to do it. But it is a wise precaution to turn that stuff off and mask your implementation details that come out through introspection and errors in your GraphQL in these environments. Next, we're going to talk about quotas and rate limiting, which is something that we are typically getting involved a lot in our customers' APIs. So your dad's rate limiting is not going to cut it with GraphQL, unfortunately, because simple rate limits and quotas are counting on a per request, right? Per request at an HTTP level. But GraphQL gives a lot more control to the client side to control how much data a query can return. You get that control by specifying in your query the different properties that you want back. So that means that for a single transaction, you may have a little or a lot of data, and like by a lot, right? And on top of that, GraphQL lets you combine as many queries as you want in a single request, right? So maybe something that required 10 different API calls in your REST API can be done in a single call with the GraphQL. And that's one of the reasons in the first place why people choose GraphQL. And so if you're counting on a per request basis, you're not really getting as much relevance as you were with your REST APIs. So GraphQL introduces, or at least increases, because it's still, for some REST APIs, relevant to do cost analysis. But in terms of GraphQL, it is really a big problem. You need to do a per transaction cost analysis for these queries. And so from the perspective of your DX, right, the relationship that you have between the API provider and the app provider, GraphQL changes a number of things when it comes to quotas and rate limits. So think about API plans or monetization tiers that are typically associated with a number of queries, and the way that you explain that to your client-side developer, that changes a lot. What you need is a design cost estimation as part of the DX. If you're going to charge a developer money for calling your API, and before you were telling them, whatever, for $10 a month, you can do 1 million transactions per day or whatever your model is, and now it's not the number of calls anymore, it's per the cost of your API. I need to know ahead of time, before I make my call, how much it's going to cost me, right? Because I'm paying money for this. So you need to provide something that you didn't have to provide before. So let's talk about query cost analysis. So you got to watch out for these graph bonds. So this is James Davis has a really, really good article on a topic. So if you're interested in that, I would definitely point you to that article. Titled that's not the title of the article, but it's a quote from it. GraphQL's expressiveness is risky for service providers. So understanding the cost of an incoming GraphQL query helps protect your API against DOS and just general API abuse. It's not just for monetization, it's also for security. So you want to allow cheap queries to flow. You want to restrict expensive ones. You could substitute expensive for dangerous here if it's more relevant to you. And you want to detect and monitor these signs of abuse. So there's different ways, different types of cost analysis that I'm going to present here. Some of them are things that we know customers are doing, and the third one is something that's I think is a pattern that we're going to start seeing, but it's not necessarily something that people are doing yet. Let's start with basic analysis. So I've got screenshots of the GitHub GraphQL API, and at the bottom here, look at that calculation, right? You've got you're querying a number of entities. In this case, they're repos. You're querying pull request, and you're counting all these things, and then you get a number of points associating with the GraphQL query. So that's a basic way that you can explain that to a developer, and they will understand how the queries that they're building translate into a complexity that affects them from a monetary perspective, or maybe from a latency perspective. So basic cost analysis strategies. So nesting is an obvious one, right? You don't need a lot of GraphQL intelligence to be able to calculate that. You don't need any, in fact, right? Before we had any GraphQL context in the layer 7 gateway, we could determine the nesting just by passing the query through a really simple JavaScript and just counting what the nesting was, right? And you can set hard limits for that, right? You can say you can't have more than 100 levels of nesting in your GraphQL query. Or maybe you're going to throttle the ones that go beyond a certain limit. That's simple. Another simple way is looking at pagination. If this is baked into your GraphQL contract, into your GraphQL schema, you can use that to get an estimate of the response size, because response size is associated to the query cost analysis, right? The bigger the response, then presumably the more work you have to do, the more traffic goes over the network, and that's one of the things that you're interested on. And then basic query cost token counting strategy, that's what I was using that GitHub API as an example for. And it's important that you make it understandable to your developers. And I think GitHub, their API, they're doing a good job doing that there. It's even visual, I like that. So that's a really good example of that pattern. So that's query cost analysis, the basic mode. let's look at the cost modeling approach. So the cost of a GraphQL query can be evaluated according to two different things, right? So there's the resulting response size that results from your query, right? Which is something that you may be able to approximate. But there's also the computational cost of an API call, which is not necessarily always directly proportional to the response size, right? 100 megs of data sometimes is a lot easier to get to than a very specific piece of information that's much tinier. So that second one there, that's the one that's a little bit harder to analyze. So estimating a query cost, without first executing it, requires this concept of cost modeling. So you define weights throughout your schema. You model a total cost estimate formula. So how do these different weights relate to each other in order to add up to a total query cost? And so this is hard work. It's kind of like a combination of science and art. And you have to think about also the cost, the computational cost associated with the actual application of the analysis itself. If you're adding 10% computational cost just by doing the query cost analysis, that might be a big problem. Also, if the modeling that you're doing is so complicated that you can't explain it to the client-side developer, and there's a consequence to a high query cost, that's a problem. And if that's the case, you would need to provide some sort of cost estimate service, right? I can imagine where you would have a place where you're saying, as a developer, I'm going to go in. Here's the GraphQL query I'm considering. I can pass it through like a cost simulator if you want, and I get that cost back. You would need to provide that service to your developers if you're going to have a consequence associated to the GraphQL query cost, especially if there's no simple model like GitHub is doing. And the good thing with cost modeling is that you can actually test it. So yeah, the cost modeling can be tested with synthetic GraphQL traffic generation. So you can pass synthetic GraphQL traffic into your API and validate that the cost that you were expecting is proportional to the cost that you're measuring. So you can validate the model assumptions using that technique. You can appreciate whether for different types of queries you're overestimating or underestimating. You can test different assumptions, pass it through the testing and see if that improves your modeling. Is it more accurate, closer to real world complexity? And you can improve your model over time. So query cost analysis can be a very effective way of achieving this. I mean, cost modeling. Now, the third mode that I want to talk about, is the cost learning and AI and machine learning and using those techniques to kind of like appreciate the cost. Something is very trendy, so I want to put this out there. So the idea is that instead of trying to estimate ahead of time how expensive a query is going to be, you just measure it. You just don't try to measure the cost of the query before executing the query. Just execute the query, measure how long it took to come back, measure the size coming back, and now you know. You might say, well, it's too late. You already let the query happen. It's true, but it still can be very helpful. And so you can have like an allow list or a whitelist strategy where you would remember your cheap queries and you would put them in an allow list, and you don't apply any additional restrictions to those API calls. This works really, really good if you're in a system where the same queries keep coming back. So you've got like your 100 types of queries that always come, so you have a predictable thing, And anything that falls outside of that, you can add additional scrutiny to. So you assume that if it's not in the allow list, it might be costly. Therefore, you might do throttling for every API calls that are not matching something in your allow list. That's the allow list strategy. Or you can turn this around and remember the costly ones and have a restricted list tuned model where you are assuming that a query is going to be cheap. But if it is not cheap, if it turns out that a query is very expensive, then those are the ones you would want to remember. And then whenever you detect a new query that fits one of the ones in your restricted list, you would apply that or the additional throughput, for example, or you might block it, and then you can have this different list for different levels of complexity if you want. So like I was saying, measuring after execution can still be helpful in protecting the service provider, again, because if you're in a system where you've got the same queries coming back over and over again, this is a very simple and effective way of doing that. So that's cost learning. Cost learning continued. So one of the challenge, if you're not in a situation like I was saying, where the same queries keep coming back over and over, then you have a problem, because GraphQL gives you an infinite ways to express even equivalent queries can be expressed in lots of different ways, like some of the examples that we saw earlier in the presentation. So you probably need some sort of GraphQL query normalizer where maybe you're ordering the query fields alphabetically, maybe you're normalizing whether it's inline versus variables and things like that to make it easier for you to switch between a really complex query and a simple one. Query cost analysis using cost learning will introduce some runtime complexity, right? Your architecture needs to accommodate this learning over time. You need to remember these expensive queries or the cheap ones, depending on the strategy that you're using. So you need to remember these things somewhere, and whatever is responsible for validating that query cost over time needs to be having access to that information. You need to synchronize that potentially over different portions of your architecture. So is artificial intelligence potentially helping here, right? This is what a lot of people are wondering about. Can I use AI to take care of my GraphQL cost learning? And I think the answer is no, because if you're doing it in real time, the cost of the AI is going to be prohibitive, right? And if you're not doing it in real time, then you don't need an AI because you already have the ability to measure it. It just happened. How long did it take? How big it was? You don't need AI for that. It already happened. So I actually think that cost learning for GraphQL probably does not involve AI at all. So we're almost done on this topic, but let's talk about the OWASP API Security Top 10 from a GraphQL perspective. So hopefully you're familiar with this list of top 10 vulnerabilities for APIs. It's something that people are looking at to validate, what kind of vulnerabilities they might have for their APIs. So which of these are most affected by introducing GraphQL as opposed to REST? So I've highlighted a couple ones. So the first one, BOLA, Broken Object Level Authorization. That's the #1 vulnerability for APIs, something that a lot of API providers are worried about. And I would argue that BOLA is definitely impacted by GraphQL, because in order to understand if you have a BOLA, you need to be able to appreciate which object is being acted upon. And that's, in the case of GraphQL, that is a little bit more obscure, a little bit more buried deep down in the GraphQL query. So that is affected by GraphQL. Broken authentication, again, there's nothing specific, GraphQL specific about your authentication, so that's probably not changing. Excessive data exposure, I think that In some ways it applies because GraphQL gives you control to access different things about your API, but so does REST, right? Lack of resource and rate limiting, definitely, right? Because of the query cost analysis I was talking about, I think that GraphQL definitely affects that. Number 5, broken function level authorization. So if the object is buried deeper, so is the function, right? So because the function is buried deeper, then it is harder to evaluate, and so introducing GraphQL might introducing more complexity for you to determine whether or not you're vulnerable to any of those. Injections are also potentially buried deeper into the GraphQL, which is why I highlight that. Which takes me to my last slide. And in conclusion, I would say that when infrastructure fails to evolve GraphQL awareness, and what I mean by evolving GraphQL awareness, I mean that your otherwise HTTP aware middleware becomes, evolves some capabilities to interpret GraphQL. When you fail to do that, the GraphQL implementation takes a greater share of responsibility. Like I said, you need to pass the ball to your downstream application developer. So the existing infrastructure has to evolve. You might need to introduce new specialized solution that will address the security needs that are introduced by GraphQL. The loss of context in infrastructure from transitioning to GraphQL is a fundamental problem that goes beyond security. If you think of that use case I was talking about where that telco wants to route GraphQL based on input parameters. And just in general, opacity is bad for API providers. So that's one of the consequences of GraphQL being introduced. So I will take questions now, if any. Yeah, so I've got a question about how does GraphQL relate to microservices? So for the same reasons that people look at GraphQL for merging different sources of data together, GraphQL often saves the same purpose. So sometimes you will have a GraphQL gateway, if you want, into multiple microservices. But if a microservice exposes an API, there's no reason that itself cannot be GraphQL. So, are we going to start seeing microservices themselves having a GraphQL interface? I would say for sure that's probably going to be the case, yeah. Any other question? Yeah, in the back. No, I think it is a good pattern for abstracting the different services with a common interface. I think that's what you're getting at. I think GraphQL is a good choice for that. Yes, that can definitely be something that is going to be needed for your GraphQL API. Yeah. Okay, thanks. I will pass it to the next presenter. Do you believe it's Frank? Just no? A little bit of a change. Oh yeah, well we're switching things around. Okay, yeah. Sounds good.
I just have one last question.
Yeah.
What are the best use cases to use GraphQL?
Okay, I actually have another presentation tomorrow, which gets into those other types of questions that you guys have been asking for, but I'll give you a preview of that. So you're about to implement an API, you're wondering if you should do it in REST or GraphQL, right? A lot of people are going through that. So think about GraphQL, right? It's very data oriented. So is your API data oriented? Because if that's the case, then probably GraphQL is where you need to go.
What do you mean by data oriented?
is your API a way to access data? Is that the primary function of your API as opposed to, you know, having a function or something like that?
Like turning a light switch on or off.
Yeah, exactly. Yeah.
Of getting the information about when the light switch was turned on and off.
Yes, very good example, Aaron. Thanks. Yeah. So an API can be about turning on and off the lights, or it can be about getting the data, who turned on the lights when, or how often, or which room has lights in, or stuff like that, right? So if an API is about that kind of pattern, like really data-oriented API, then yeah, GraphQL is almost always an obvious choice. But the argument that I'm doing in my presentation tomorrow about GraphQL is that in cases where it's, even if it's not about the data, GraphQL sometimes is still a good choice. So I would argue that very often is going to be, even if it's not about data.
So it is more than a read access than a write access, which is being used in the both.
I don't know if it matters so much about whether it's more primary read or primary write. If it's about data, then I think GraphQL is a good choice because it gives you more control. You're welcome.
Hello everybody, so I'm Christian Auberlet, Solution Architect at Broadcom. Been with Broadcom CA Technology since, has been for 5 years. Looking at our major customers in Europe, so I'm based in Paris. And today I'm going to talk about API and cloud and acceleration, because I think this is a very interesting topic. So, you know, unless you've been living in a cave, a lot has happened over the last 10 years. I think this is nicely illustrated by these two pictures. Some of you may remember the first big crisis we have 10 years ago, almost more than 10 years ago, in 2008, 2009, when there was this economic crisis and the credit crunch. And you know, everybody said it's going to take 10 years to recover. And 10 years after, we had a new crisis, which is COVID-19. So, you know, everybody says, oh, it's going to take 10 years to recover. And a couple of years after, now we have the Ukraine war. And the question is, what's next? What's the next crisis, you know? Yeah, what's next? And the underlying, you know, the other picture that you see here is a picture of the Mer de Glace in the Alps. So that's, I think, the underlying crisis that is, you know, the pillar of all those crises, you know, although not directly related, but everybody knows that, you know, there is a global heating, global warming, and I think this is maybe the major crisis that we have all to take care of. So you may wonder at this stage, well, this guy is talking about a crisis, but how is it related to APIs? And you will see a couple of consequences of all these crises. Today, I mean, we are, you know, in the API days in Paris. It's 10 years that API days are existing. So you may think 10 years, it's, you know, APIs have been here for a long time. Yeah, already 10 years. So there might not be a direct correlation between, you know, the first crisis and what you see here, you know, around 2008, 2010. But what you see here is definitely a gradual increase in API usage. And API, I wouldn't say have been, are now a commodity, but you know, if you remember, you know, the pitch from Jeff Bezos in 2002 saying everybody has to be based on APIs, you know, it feels like it's history. And since then, APIs, that there was a slow growth, but now, you know, it's a steady growth, and everybody is using APIs, and undoubtedly is the pillar of the digital economy. You know, if you look at other charts, and you'll find lots of data, you know, everybody's using APIs, where it's for building application or, you know, internal usage. But basically, API have big benefits. You know, if you have an architecture that is built on APIs, you are much more agile. You can react to the market much faster and react to the crisis, you know, because each crisis has an impact on the market, and it also enables you to be customer-centric. And I think this is what is really important is, you know, I need to build a company, or I need to build an economy, but what matters most is customers, because customers bring revenue. So I think this is a very important consequence. The second consequence, I think, is directly related to COVID. Many people have been working from home. Okay, I mean, this is now becoming an evidence, and it's funny because I don't know if you're traveling in Paris, but it's the first day in the year that we have snow in Paris this year. And I heard on the news last night that the government was recommending people to work from home. So, I mean, it's funny because before COVID, nobody would say stay home. And now everything, whenever something happens that may have an impact on the traffic, we say, hey, work from home. And it's becoming commodity. But the big impact of that is the size or the periphery of your organization has changed dramatically. I think this is really fundamental. It's a fundamental change that's, with people working from home and with partners and with a very decentralized organization or very decentralized organizations, you have to put in place new technologies to ensure that you basically ensure who is going to get access to your data. And the APIs is really, one of the big role of the APIs is ultimately to get access to your data. So you have to put in place new platforms like zero trust networks. Never trust, always verify is becoming the motto here. Is even if somebody comes in your organization, you need to verify. Even if they claim it's somebody you have to verify, and that has an impact on how you are going to use and how your API platform is going to look like. The third consequence, I mean, I love this chart, right? On the left-hand side, you see a direct connection between the start of the war in Ukraine and the number of DDoS attacks. Okay, cyber war, cyber crime, cyber X, I would say, was something like science fiction a couple of years ago, and now everybody talks about it. If you go into the street and ask people, oh, have you heard about cyber war? It's highly likely that people will know what it means. Okay, so this is becoming a commodity, and again, APIs, are very, I would say, if you open the purpose of API is basically making your organization much more agile, etc., etc. But you're opening up your organizations, and you are opening up doors, and therefore you have to protect those entry doors into your organizations. Even more so because you have all those threats now, which is also becoming something we have to live with, for the coming years. And it's not something that is going to disappear. On the other hand, it's going to accelerate. The other data here is the IBM data breach report. And if you're interested, this report is actually available for free on the internet. So it's just type IBM data breach report. And if you think about it, it's amazing to see that 83% of organizations have had a data breach over the last 2 years. It's not 10%, it's not 50%, it's 83%. So basically that means that there is no organization out there that will not be attacked at some stage. The other big number is the cost. The cost of a data breach is tremendous. Okay, it's on the average 4.35 million. So think if you're a small company, you basically can close your company because of that. So it's a direct consequence of running the world on APIs. With all the crises that you have, well, you also expose yourself to risks. The fourth consequence is the cloud adoption. And, everybody is talking about the cloud. And the cloud, why everybody is going to the cloud? Okay, there are many, many benefits. So today, I think it's kind of a given that your architecture at some stage will have a step or foot in the cloud. Maybe not everything, but something will be in the cloud, undoubtedly. I mean, when we talk to customers, we have customers that say, well, we want to put everything in the cloud. No, full stop, for many reasons. Some says no, no, there is some data we cannot put in the cloud. We're going to have an hybrid architecture. Between those two, and do you have companies that are really, cloud? They want to stay away from cloud for many reasons. So between those extremes, you have all the shades of gray of the companies that at some stage will go in the cloud. I put here a few, I would say not buzzwords, but the reasons why you go to cloud. These are most of the reasons, and you can put, you can pick any of these words. Clouds provides you those benefits. It helps you to be customer-centric with customers 360 vision, because you have analytics, you can control everything. It also enables you to start servers very fast, so you can innovate much faster. It also provides you, you can, one of which of these term, you can think, why does he put security with cloud? Well, it's safer for you, and I've seen this with many conversations I had with customers. It's safer for you to go in the cloud and to leverage the security framework that a Google, Amazon, a Microsoft, or another cloud provider will put in place than trying to put in place these security walls around the organizations, because the knowledge is getting so complicated, so complex, and evolving so fast that it's actually safer for you at some stage to go in the cloud. No, it's maybe contradictory, but the fact is that the cost of maintaining a secure architecture can be pretty high, and actually you can benefit from what a cloud provider has to offer. So all these are all good reasons why at some stage companies are going to the cloud. And of course, working from home is also a direct consequence of cloud adoption, because when you have to share documents, etc., you basically go, in the cloud. In the company I'm working, which is Broadcom, it's kind of forbidden to use a USB stick to exchange documents. It's forbidden. We have training programs, and you sign up to say, I'm not going to use a USB stick. And they also tell us, if you find a USB stick somewhere in the room, never plug it in your computer, because you can, infect all the organization. So cloud is also, important from that angle, and the direct consequences of, the working from home and the COVID. As I said, companies are going to the cloud, but one big thing that we see as well, is they don't go to one cloud. They go to multiple clouds. So that's an important factor as well, that if you go to the cloud, usually balance your IT across different cloud providers. And there are lots of good reasons why you could that. Some clouds are very specific for some applications. For example, it's pretty well known that, and Google business is around crunching data. And Google has developed a lot of algorithms. It's their business. It's how they breathe and live, right? By crunching data and analytics. So for companies, I have companies I'm talking with that basically said to me, we're going to Google Cloud, not because they are cheaper or not because they have a wider network. It's because we want to leverage their analytics and big data algorithms. Some of them may say, we actually prefer to go to Microsoft because actually our organization is a heavy user of Office 360, and around that they provide lots of security, software, etc. So the reasons why you would go to one cloud or another are very dependent on organizations, and organizations tend to have a kind of best-of-breed approach by saying, okay, for these applications, I'm going to this cloud provider, and for other applications, I'm going to another cloud provider. And maybe some cloud providers have a better network in these regions and a better network in these regions. So they really balance their architecture over the cloud. And if you think about that, application used to be monolithic, right? And what has happened to application is they were broken up into many microservices and etc. So we all know containers, okay? But now you think about it, it's not I deploy a container to a single cloud. I deploy my container or my application. It's kind of scattered around multiple clouds. and the level of complexity just goes on increasing. Okay, the more cloud provider you use, of course, the more complexity you have. So at some stage, organization will have to handle this complexity and handle the scattering of their application across multiple clouds, etc., etc. So the complexity goes up, and this is something I believe is a trend. How and where, how far it will go, I'm not able to predict it, but I can foresee that either company will then go back and refrain from going to the cloud and actually think, being on premise was not bad after all. Or they will balance and they will not move everything to the cloud, but just put the cursor more to a 50-50 architecture. And I have customers, they put the cursor to 30% in the cloud, 70% on-premise. So at some stage, we went from everything is on-premise to cloud is the new thing. So everybody went to the cloud. And I think now the cursor is maybe going a bit more toward a balanced architecture. But anyway, the message here is you basically will at some stage leverage multiple clouds. So the question in here is, how are you going to accelerate? Because the world is accelerating. We see the number of APIs being used is increasing. So, what can you do, and what can you do to accelerate together with this, all these new trends? So, these are a bit a result from conversations I'm having with customers. But the first thing I would say is, you at some stage will have to embrace new standards to access your data and protect your APIs. As I've said at the beginning, Apidays, we've been around for 10 years. What's new in APIs actually? We went to SOAP services, to REST services, with a clear benefit for mobile applications, and the overhead of SOAP messages was pretty heavy, so it was clogging the networks, so not scalable for the millions of applications out there. So now you basically have, I just came in the room when Francois was talking about GraphQL. Definitely GraphQL biggest benefit is to get some data with a REST query. You have to make 3, 4, 5, 6 queries. In GraphQL, you just make one, and you have the data you need. So it's more data oriented. Like gRPC and new protocols, you also have WebSockets. So you have to think, and I think this is one of I have it's also a question in the next slide, but how old are your APIs, and are my APIs still aligned with the new standards? Especially when you think about one of the earlier graph I showed where we talked about zero trust networks. How am I enforcing my security? Am I still leveraging OAuth 1? Nobody is talking about OAuth 1 or TLS 1. So, security protocols are evolving, and you have to have your APIs evolve with these new standards. A lot of companies out there talk about APIs like products, and APIs are like products, right? Back in the days before my Broadcom days, I was working with a company called Mashry. Some of you may know this company, and it was basically saying API are products, and I think they are right. APIs have become products. So when you have products, you have new versions of the products, and you have to think about that, and how am I securing my APIs? Are my APIs using the new standards? Am I using token-based security? And also, there has been a lot of evolution and around OAuth, with token inspection, audience restrictions, like giving an access token that is valid just for one URI and not for everything. Using mutual TLS, so associating a token with a certificate to make sure that the person using the token is rightly authenticated. When you have more and more microservices, you may have to have needs for token exchange. And the last is using financial API security with baseline and advanced security profile, which basically makes the authentication much stronger when you use a token. So these are all things that you can do and you should think of when you develop your APIs these days, because your APIs have been there for, as I said, many, many years. The other thing is, if you want to accelerate, you have to modernize your architecture. There is no way you can accelerate with an old architecture. So, how can you modernize your architecture is basically, as I said, how old are my APIs? Do they need a refresh? And can I still carry those legacy APIs forwards, or do I need to have a refresh? Importantly as well is, as I said, APIs are the entry door for cyber threats and cyber attacks. So how do you analyze your audit logs? Do you have the right audit logs? Do you store a lot of audit logs? And how do you analyze and rotate your audit logs? Is this slowing down your platform? How do you monitor your APIs? Do you have the right monitoring tools in place? And have you done some performance checks, to be sure that if there is a DDoS attack, you're still there, you're still protected. Are you compliant with new regulations? As I said, new threats are emerging, regulations change. We are no longer using TLS 1.0 or OAuth 1.0. You have new standards there. So what about your platforms? Are you embracing OAuth 2.0 and the new OAuth features that I was talking about? Other example is customers, as I said, API enables you to react fast and to be customer centric. So how fast can you add new APIs? How quickly can you launch new applications? How is your CI/CD pipeline created? Is it built on APIs? And do you have a full pipeline to go from inception and innovation to product and delivery? So this is crucial as well. How fast can you launch new services and new APIs? Is your API platform resource hungry? I think this is going to be the challenge for the next coming years. If we think about the first slide and the usage of resources, the more we use application, the more we use APIs. And do you have APIs out there that actually nobody is using, but they are still consuming some bandwidth and some CPU on your network? So think about that. Think about your energy bill. Think about your platforms. It's very important as well. And as I said, do you have a zero trust network in place? Do you have multiple factor authentication in place? What can you do, and what should you do to protect your organizations and all those open doors that APIs are representing? The last slide is about the multi-cloud. So by 2025, more than 85% of organizations will be running containerized application. So again, microservices, containers, all of that is going to be a commodity. But I like this chart because if you looked into Kubernetes, it's pretty complex. It's not an easy journey to go from on-premise application to a cloud-based architecture and application, and so so it is for multi-cloud platforms. So the first question is, are you cloud ready? If you have to go to the cloud, do you have the resources and the skills to go to the cloud? It's a fundamental question. I hear from many customers that they have difficulty to find knowledgeable resources around Kubernetes and around cloud, managing the ecosystem for Kubernetes. And also, are you comfortable in running your applications in the cloud? As I said, there are different shades of gray between I have everything on-prem, which basically means I'm less agile, or I have everything in the cloud. Where do your organization fit? And how is your executive team embracing this cloud journey? Is your API architecture cloud ready? Fundamentally, are my APIs so old that actually I can't even think about moving them to the cloud with auto scaling, etc., with all the benefits that you can have with a Kubernetes platform? Or I just have to do a big work to basically redesign all my architecture before I go to the cloud? Do you plan to go to the cloud and avoid cloud locking, or are you just intending to go to one cloud provider? Have you looked at the market for cloud providers? Have you looked at the costs of your cloud provider? And have you drawn the line between being everything on-prem or being everything in the cloud? So these are all questions that I wanted to share with you today, because it's a good conversation that we are having with our customers. These are the conversations we are having today. So I didn't want to intend to educate you on API, because I'm sure you know very well what an API is, but more to talk about the acceleration and also to see the impacts that the crisis we are having directly have on your IT. So IT is definitely not disconnected from the world. It's something that is, it's a living beast, right? And you have to follow the trend, and as much as you can if you want to basically accelerate and have a successful API platform and a successful business. So I'm open for questions. This was this short presentation on acceleration and cloud readiness. And if you have questions, I'm really happy to address them. Thank you. Yes.
Is about, is your platform ready for cloud or Kubernetes? Is there
This one, I think.
Is there a significant roadmap for layer 7 as well, that is supporting natively?
So I can talk about things of today, and I can maybe talk about things of tomorrow. The things of today is that we are definitely, layer 7 is cloud ready. We basically, the first version of the gateway that was deployed for on container was in 2019. So we've been running container gateway since 2019, and we have at least 5 customers, large customers that I know, that are running fully on cloud, on containers. So no question about that. And we provide a lot of things to be cloud native and running on cloud. No, sure. Yeah, it's fine. So no. Yeah, so no, it's. I'm responding. I'm very open. We are cloud ready, and we have the experience. We have very talented people in our team that have been deploying platforms in the cloud, and we're going to be even better. I'm sure you've heard about the acquisition that is ongoing of VMware, and VMware has a platform called VMware Tanzu, and stay open. I think there will be a lot of things positive for our customers with this acquisition, and especially with API management and gateways.
The bottleneck, okay, we can explain and scale how much we want there in the cloud, but bottleneck comes from the policy lending repository for us, for me at least. So the banks, they don't accept you. So you understood?
Yeah.
We don't have a clear answer for that yet.
We can have a side conversation about that and go more into details, but I hear 2 things. I hear customers saying, it's nice to have MySQL database, or a database where we store the credentials, because we know it's well monitored, and we know that we have the experience, okay, for managing the storage with a MySQL database, okay. We can do backups. It's something that we have been doing for years, and everything works well. Some other customers say, no, I want to have containers that run, without a database, and that are database-less. And we have that as well. So we have both technologies up and running, containers or gateway with and without MySQL database storage store. And, it's kind of, you choose. We have a container gateway that can run without the database, yes. And we basically are looking at an architecture where policy will be stored in a Git repository through bundles, etc. So that's a bit off track, the presentation, but we can have conversations on that. Yeah. Yes? Unfortunately, there is not much I can talk about because it's not done. So as long as the deal is not done, we can't talk about. But VMware, basically, what I can say is VMware. Kubernetes is open source, right? So Kubernetes is an ecosystem, and VMware, like Microsoft, like others, are supporting Kubernetes, and the Kubernetes of VMware is called VMware Tanzu. And VMware Tanzu is basically simplifying the management of the ecosystem. So it makes it much easier for customers to embrace Kubernetes.
But why you will not use something? You can use something like Terraform.
It's too early for me to be able to talk about that, to be honest. I know it's.
I am asking because we are our private cloud is at OVH.
Yeah, OVH, yeah.
We do not provide Tanzu for now. So maybe we will go to hybrid private and public cloud. I was just asking if you see there are features for their solution.
It's very hard for, yeah.
Something like Google, iOS.
From what I can anticipate is VMware is a virtually no. This is all I would say from what personal thinking, right? It's by no means anything that a message shared by Broken, whatever. It's my personal feeling. VMware is very strong in virtualization, right? So if you think that you have multiple clouds, what you want to do is to have the ability to deploy an application that is on one cloud one day to move it to another cloud the other day very easily. How would you do that today? And I believe VMware Tanzu has the ability to have this abstraction layer that sits on multiple clouds that enable you to move things around. Okay, I think I see this as as something happening in the future. Okay.
Isn't that what Kubernetes do?
Kubernetes is a framework. So you deploy the framework either in Google or Google has GKE, Amazon has EKS, but it's Kubernetes. But say you have an application that is today running on GKE, you want to deploy it in a click to Amazon, for example, or to somewhere else. It's complex. VMware would have this abstraction layer where you can say, okay, I have servers that are on-premise, I also have the cloud, and I can balance my architecture over those platforms. Using this abstraction.